take a random guess at a number that it might be divisible by, we have a rule that will help us get a potential list of numbers that should work. So that way we're not just taking a random stab in the dark. It says here that if you have a polynomial in this form, so remember, normally our polynomials start with the highest exponent and then they get smaller as it goes down, right? So normally we start with like the fourth power, the third power, second power, linear term, and then it actually ends up with a term that doesn't have a letter in it at all, right? Like for example, we've seen the equation maybe like 2x cubed plus 2x squared minus 4x plus 5, right? So exponent was 3, and then it was 1 less. This is understood to be 1, and then this one didn't have a variable at all, right? Okay, it says that in these equations that the term q is going to always be whatever the coefficient is of the biggest exponent. So in the equation I just gave you, the biggest exponent was 3. So q should be the coefficient of that part, okay? P should always be the term at the very end with no letter in it, okay? And then it says you will come up with a list by finding the factors of q and p and writing them as the fraction plus or minus p over q. All right, so first we're just going to practice using this method to come up with a list. So it says list all possible rational zeros. So basically list all the things that it might possibly be divisible by. What are the things that we could divide by? So remember I said q should be the first term, right, with the highest exponent. Well, our highest exponent is 3. So what's q? The 2. Right here. So this is my q. All right? And then p is the term that does not have any variable with it. So what's that for us? A 3. All right. So we are going to start with just listing their factors. Before we try and put them in a fraction, let's just list the factors of p and q. When I say the factors, that means what multiplies to give us that number. So for p, you guys said our number was 3, right? What are the things that multiply to give me 3? 1 and 3. So now 1 times 3 gives me 3. -1 times -3 would also give me positive 3, right? So to cover our bases, we consider all of them to be a positive and a negative. So my list just has plus and minus 1, plus and minus 3. Okay, now I'm going to do the same thing for q. Here's my q. You guys said it was 2. What multiplies to give us 2? 1 and 2. Again, could be a positive and a positive or a negative and a negative. So we're going to list plus and minus 1 and plus and minus 2. Okay, then it says to come up with your possible rational zeros, you're going to write them as the fraction p over q. And since all of them have plus minus, in front of them all, we'll put a plus minus. Okay? So now we're going to make our lists of p over q. Well, my first option that we had for p was this plus minus 1, right? And the first option I had for q was this plus minus 1. So if I write those as a fraction, it would be 1 over 1. Can I simplify 1 over 1 down to just 1? Okay, so my first option simplifies down to just 1. Okay? Let's say that I keep that plus minus 1 for p. I could get another combination by changing q to the other option, which was the 2, right? So then I'd have 1 over 2. So I'm going to add that. I'm going to add that to my list. Plus minus 1 over 2. Okay? So that's all the possible combinations if I'm using 1 for p, right? Now let's try using the 3 for our p value. So for p, if p is 3, I could do 3 over 1. And 3 over 1 simplifies to just 3, Okay, so let me add that to the list. And then the only other option would be to put 3 over 2, right? So plus minus 3 over 2. So these would be all of the things that potentially this function could be divided by, okay? So remember, this would be a good time to use synthetic division because normally they say divide by x plus 1, right? Or divide by x minus 1. And we have to take it, set it equal to 0, and solve, right? Here, it's already solved for. So you would just go straight to your synthetic division. You'd put a 1 in there and do synthetic and see if it works, okay? All right, so for part B, what is my Q? One. All right, remember Q is with the highest exponent. So Q is 1. And what's P? 16. Okay. So for P, what are all the things that multiply to give me 16? Right. 1 and 16, 2 and 8, and 4 and 4. So 1, 2, 4, 8, and 16, right? Okay. And then for Q. Q was 1. The only thing that multiplies to give me 1 is 1. Okay. So now I want you to write those as a list. What are my possible ratios of P over Q? After you make that list, go ahead and try part C by yourself. See if you can come up with the factors and then write them as the ratios of P over Q. Okay, can somebody tell me what our list was that we came up with for part B when we wrote them as P over Q? Somebody want to share one that they wrote down? Good. All right. Anybody else get something else?
Plus and minus 2.
Good. Anything else?
Plus and minus 4.
Uh-huh.
Plus and minus 8. Plus and minus 16.
Nice. Good job. So those are all of our potential zeros. All of these are ones that might work. Okay. Then I asked you to go ahead and give part C a try on your own. So first thing we would have needed to do is write down our factors for P and our factors for Q. So what did you guys say that the factors for P were? Remember, this is P over here, right? Okay. What else? 3. Okay, what else? Okay. And 6. Nice. Okay, so that covers all of our factors for P. What did we come up with for Q? Mm-hmm. And 4. Nice. Okay. So now we just needed to go and write these as a ratio. All right, so maybe we start with that first possibility for P and put it over our first possibility for Q, right? And what's that going to simplify down to? Right, so just 1 for that first one. Okay, let's say we keep the 1 for P and we trade it for our next possibility of Q. What's that going to be? 1 over 2, okay. Any other combination we can have with P as 1? Mm-hmm. Good. Okay, so all combinations have been exhausted now with P being 1. Now I'm going to change P to 2. So what do we come up with there? Mm-hmm. So 2 over 1 simplifies to 2. And then if I did 2 over 2, what does that simplify down to? 1. And we already have that one, right? So I don't need to write it again. Okay? Then we could do 2 over 4, but 2 over 4 simplifies down to 1/2, which again we already have, right? Okay, so now let's do our 3. So we would come up with 3 over 1, right, which would just be 3. And then what else would we come up with? 3 over 2 and 3 over 4. Perfect. Okay. And now we just need to use the 6. So we would have 6 over 1, or just 6, right? And then I could put 6 over 2, but 6 over 2 simplifies to
3.
Which we already have, right? Okay? And then I could put 6 over 4, but 6 over 4 simplifies to 3 over 2, which we also already have, right? So this is going to be our entire list. Okay, perfect. So now that we have the hang of how to come up with the list, let's talk about where we would actually use this list that we're coming up with. So number 1 says we're going to use synthetic division to find the factors for the following functions. But if I'm going to use division, I got to have something to divide by, right? So that's where our list comes into play. We need to make a list like what we just made, so that way we know what to divide by. So what would my factors for P be on this example? Here's P, right? What multiplies to give me -3? -3 and +1, or... Right. So again, we're still going to have to put the plus and the minus, right? Because it could be either combination. Okay? Then my Q is 6, right? So what are our factors of 6? And what else? Nice. Okay. All right, so now we are going to list out all of the possible rational zeros. So all of the P over Q. And that's what they want on this line right here. They want P over Q on this line up here. So first we could have 1 over 1, which is really just, right? Then I could have 1 over 2 or 1 over 3 or 1 over 6, right? Okay. Now I'm going to use them with 3 as the value for P. So I'd have 3 over 1, which simplifies to just 3. And then I'd have 3 over 2. And then I would have 3 over 3. 3 over 3 simplifies to 1. And then we'd have 3 over 6, which simplifies to 1/2, right? Which, again, we already have in the list. So this is it, right? This is our whole list. Okay. Now they ask, what are the actual rational zeros? Or in other words, which ones actually work? Okay. So this is where we try using the numbers from the list. Okay. If it's me, I'm picking the whole numbers because I don't want to do synthetic division with fractions, right? So let's try the whole numbers first. So first option I've got is a positive 1 or a negative 1. So let's try synthetic with a positive 1. Remember, you put that number in the box, and then you put the coefficients. Well, the coefficients from our equation would be 6, 5, -8, and -3, right? Okay, then I bring down the first term. Then I multiply 6 times 1, and then I add. What do I get when I add? 11. Then I multiply again, 11 times 1, and what do we get when we add? 3. And then I multiply 3 times 1, and what do we get when we add? 0. All right, so that means this one did work because we did get a remainder of 0, right? It went in as a factor. Perfect. Okay, so that's a good start. Now that we know that this is a factor, and I have divided this down, remember, it always drops a degree from what it was. So it was degree 3. I took out an x, so this must be, so we'll have 6x squared plus 11x plus 3 is what we came up with, right? Now, when it's an exponent of 2, we know how to factor that, so we don't have to do any more division. We're good. Okay, so remember, when I factor, I ask myself what multiplies to give me the first term. So what's something that would multiply to give me 6x squared? Right, okay, so let's give that a try. So we'll plug in 3x and 2x. Okay? Then I look at the last term, and that's what tells me what to put right here and right here. So what multiplies to give us 3? And then I just have to plug them in to see if I put them in the right spots, right? So let's see. Inside, 1 times 2x would be 2x, all right? And then on the outside, 3x times 3 would be 9x, all right? And then I look at my term here in the middle, and I'm wanting it to add to give me that term. Will 2x and 9x add to give me 11x? Yeah, if they are both positives. Perfect. So we now have all the factors, right? Okay, so we have the one that we found right here, which was 1. Okay. Now these two are still written as factors. So remember, to see what they really are, you take your factor and set it equal to 0, right? So what are we going to get when we solve those factors? Good. All right, so 1, -1/3, and -3/2 are the ones that ended up working from our list up above, right? Okay, so then it does say, now write it as factors. Okay, well, these two were already factors, so I can just copy those down how they were. So I'll have 3x plus 1 and 2x plus 3. How would I write 1 as a factor? x minus 1, right? Because we have to have the opposite sign when it's in the parenthesis. All right? Okay, let's do another one. Okay, this one's going to start out the same way. So the first thing I want you to do is find all the options for P over Q. So I'll give you a second, do the P over Q, so that way we've got a list, and then we'll go from there. Oh, I'm sorry, Chase. All right, looks like most of you guys have a pretty good list there. So we've got our factors for P and Q. What did you guys come up with for your list of P over Q? 1, okay. What else? 2. What else?
3.
Okay.
6.
Okay.
1 half.
All right.
And 3 halves.
And 3 halves. Good. All right. Okay, so remember, these are the things that we're going to get to choose to divide by, right? It does not matter where you start. Again, I like the whole numbers versus fractions, but does not matter where we start. So maybe we start with the ones again. So let's see. If I put 1 in here, I'd have 2, 9, 7, and negative 6, right? So I'm going to bring down that first term. 2 times 1 gives us 2. And what do we get when we add? 11. And 11 times 1 is 11. And 7 plus 11? 18. 1 times 18 is 18. What's negative 6 plus 18? 12. Not 0. So did that one work? No. Okay, so positive 1 did not work for us. Okay, let's try negative 1. So negative 1, 2, 9, 7, negative 6. All right, so I bring down the 2. 2 times negative 1 would be negative 2, right? And 9 plus negative 2 is 7. 7 times negative 1. Negative 7, so we add and get 0. 0 times negative 1 is 0. We add and we get negative 6. So did that one work either? Okay. So what do we try next? The 2s? Do y'all want to try positive 2 or negative 2? Positive. Okay. All right, so 2, we've got 2, 9, 7, and 6. So I bring down that 2. 2 times 2 is 4. 9 plus 4 is, right? 13 times 2 is 26. 7 plus 26 is 33. 33 times 2 is 66. And negative 6 plus 66 is 60. So that one didn't work either. Let's try the negative 2. 2, 9, 7, and negative 6. All right, so we bring down the 2. 2 times negative 2 is negative 4, right? And 9 plus negative 4 is 5. 5 times negative 2, right? And 7 plus negative 10. And negative 3 times negative 2. And negative 6 plus 6 is, all right, so we got one to work. So remember, this is x squared, x, and a constant, right? So that's something small enough that we could factor it. So we got 2x squared plus 5x minus 3. Let's see if we can factor that to come up with the remaining factors. So if this term tells me what to put first, what multiplies to give me 2x squared? 2x and x, And what multiplies to give me 3? 1 and 3. All right, so inside gives us 1x, right? Outside gives us 6x. And I want those to add to give me 5. Can I make that happen? Yeah, if the 1x is negative, which is perfect because they're supposed to multiply to give me a negative 3, and a negative times a positive would do just that. Okay, so now they ask for the zeros. Well, we know the negative 2 worked, right? Okay, if I want to know what these are as zeros, I take 2x minus 1, set it equal to 0, and x plus 3, and set it equal to 0. So what are the other zeros? 1/2 and negative 3. Good. Okay. And then it wants those as factors. Well, these two, we already know what those are. 2x minus 1 times x plus 3. And how do I write x minus 2 as a factor? How do I write minus 2 as a factor? X plus 2. There we go. All right.